an associate professor in the Department of Computer Applications, Haldia Institute of Technology, Haldia. Welcome you all on behalf of my department to this 5-day online FDP on recent trends recent trends in the field of artificial intelligence and machine learning for smart computing. So today's eminent speaker of this FDP is Dr. Sriparna Shaha from Maulana Abul Kalam Azhar University of Technology. She will be delivering a speech on the topic Advancement in Healthcare in Recent Times Using Artificial Intelligence. So I think that healthcare is a topic about which all of us are really concerned about. So without wasting any further time, so let me just go to introduce our today's speaker, Dr. Sriparna Shaha. Dr. Sriparna Shaha has received her BTech degree from RCC Institute of Information Technology, Kolkata, India, and her ME and PhD degrees from Electronics and Telecommunication Engineering Department from Jadavpur University, Kolkata. She is currently an assistant professor in the Department of Computer Science and Engineering of Maulana Abul Kalam Azad University of Technology, West Bengal, India. Prior to that, she was associated as a faculty with Jadavpur University and two other institutions. She has over more than 8 years of experience in teaching and research. Her research area includes artificial intelligence, image processing, machine learning, and recently she is giving more focus on deep learning. She has over 70 publications in international journals and conference proceedings including IEEE, Elsevier, Springer, etc. She is the author of a book on gesture recognition published by Studies in Computational Intelligence Springer, currently available in many online book retailers. She is also the reviewer for many international journals. Her major research proposal is accepted for startup grant under UGC Basic Scientific Research Grant. Not only that, she also has got the university seed money for setting up her own laboratory. She is the member of Board of Studies for Maulana Abul Kalam Azad University of Technology. She has also served many other administrative duties like departmental MBA and NAC coordinator, TEQIP3, Joint Academic Nodal, etc. So, uh, ma'am is already here. Without wasting any further time, I just hand over the session to the ma'am. Ma'am, you may please start.
Thank you so much, ma'am, for letting me speak in this FDP. A very good afternoon to all, to my respected fellow colleagues, as well as the participants of today's FDP. So, today we are going to discuss about advancement in healthcare in recent times using AI. So before starting this particular presentation, so as it's a FDP, so faculty development program, so I hope most of you are faculties from different institutions. It will not be like some presentation that I will be dictate something or anything like that. It will be more like a uh, communication or more like a discussion with among us. There will be certain points that I will going to discuss, and if there is any point of time, if you feel like that I am not able to deliver properly, so please let me know. I will just try to make it much more lucid for you. So this particular topic that we are going to discuss, so there basically this session or today's session, that is basically, if you can check, it's like a 1.5 hours of a theoretical session and then 1.5 hour of hands-on session. But what I have thought about that, that theoretical and hands-on will be merged. Like a few topics theoretical will be there, then their corresponding coding will be there. That so theory and hands-on, then again some theory, then its corresponding hands-on. Without that, it will be very much difficult for you to grasp the theoretical and to merge it with the hands-on. So it will be parallel sessions will be there, few topics in theory, then its corresponding how that can be implemented in course. So I'll be sharing the screen. uh, yeah. The presentation is visible to you. Anyone can, if anyone can confirm.
Yes, ma'am, it is visible.
Yes, thank you. So, as already told, we are going to discuss about advancement in healthcare in recent times using AI, that is artificial intelligence. So, healthcare, we are going to discuss today healthcare in different topics. Healthcare from the postural information, healthcare from our cognitive, as well as, if time permit, we are going to discuss the healthcare in other domains as well. So, this particular topic, that the algorithms that we are going to discuss, that are from the artificial intelligence domain. So I hope everyone knows about it. Or so let me just give a brief recapitulation of that. What is AI? So AI, or the full form artificial intelligence. This artificial intelligence. So if something is artificial intelligence, there can be something called natural intelligence. So natural intelligence, that are from the human intelligence, like what or how human deals with their uh, code activities in each and every day, like how we apply our intelligence in solving the problem in our life. So from that natural intelligence, or the intelligence that are derived from the human intelligence, if that can be developed by some software and hardware and make an artificial agent act and behave like an human one, so then the artificial agent, we can say, have acquired artificial intelligence. So it's basically a process of transferring human intelligence to a machine. So how that does that, how we are transferred. So basically, how for this, for that, first we need to know that how we gain our intelligence, like how human gain their intelligence. So how we does that by learning. So just a very simple example of that. Suppose there is a pan that is in our gas stove and it's very heated. So should we touch that pan with our bare hand? The answer will be no. We should not touch it. Why? If we touch a very hot surface with bare hand, our skin might get burned. So that's our learning. So it might be someday we have touched a very hot surface, our skin gets burnt. So from the next day onward, we are taking precaution and we are doing it using cloth or any other tools to pick up that hot surface. So that's the human learning, and by this learning, by our day-to-day learning, our intelligence improves, and that's basically the human intelligence. So if this type of thing can be taught to the machine, then that is the artificial intelligence. So human intelligence need to be transferred to the machines such that the machine beam becomes artificially intelligent one. So that's basically we are going to do. And this thing, that is the application of AI, we are going to discuss today in the healthcare perspective, in different domains of the healthcare, how AI can be applied to get better results. That is basically today's topic. So we have discussed about what is AI. So next we are going to discuss about what is healthcare. So what is healthcare? So healthcare, uh, so very first take us one particular example, like uh, in today many people of us uh, does a very much sedentary lifestyle. We teachers, we don't have that much sedentary lifestyle. We go to the blackboard or whiteboard, then write it down, or we keep standing for a long amount of time throughout the day. We need to go to different buildings, so you cannot understand that maybe. But most of the people of this particular generation, they works in the MNCs, that is multinational companies. What they do, they try to sit in this one particular posture for a long amount of time for each and every day. So for 5 days a week, for each day they are sitting in that particular posture for like 8 hours or 10 hours. That's basically the sedentary lifestyle we are talking about. So sitting in for one particular posture for a very long amount of time, that develops certain type of elements that can be tackled if we can identify the preliminary signs of the particular elements. For example, if we try to sit in this particular posture of sitting posture for each and every day for like suppose 10 hours, it and we are working on the desktop or computer like by bending our necks, it might be that after a few months of time we can develop pain at our neck position. So that basically one type of ailment. So if someone is getting pain at the neck position, so you can check the very basic gesture they do try to have this type of gestural patterns we can find in the people who are having neck issues like problems in the neck, stiffness in the neck or pain in the neck. Similar way, by sitting with this sedentary lifestyle for a long amount of time, you can get pain at your lower back position or your knees. So these are the several gestural information. If we can read those gestural information, so we can suggest that particular person so that you might develop a very much complicated disease. So beforehand you might be alert, we can alert that person. So that's one aspect of application of AI in healthcare. During the pandemic times, as I already told that we teachers have like uh, does a long amount of time we keep on standing for making the student like from writing in the blackboard or that. But just assume for just 6 7 months earlier we were in a lockdown position, so all of us are working from our home. So this work from home concept was familiar with among teachers as well as like from the 4 hours as well. So what we have developed, what we and I can say, I think you are going to say it better than me, that the working hours were much more stressed during that pandemic times. We have longer amount of working. So that time we are working in this particular position for a long amount of time, and then it can be pain in the neck position or the lower back or in the elbows. So by sitting on for a particular posture for a long amount of time can develop this type of ailment. So we are talking about how physical health is getting hampered by this. So is it only about physical health? That might be your question. Like only our physical health is getting hampered? The answer is no. What about the mental health? So today in this session, we are not going to discuss about how we can tackle the physical health elements, but as well as how mental health elements can be tackled or it can be solved those type of problems using the application of AI. So, one example of mental health, this particular topic will be discussed in a broad way in the later sections. But for now, what the mental health we are talking about, like a particular children, suppose a child or adult, we most of the time we are very much stuck at our mobile phones. What we check, like for a particular age generation, younger age, they try to invest huge amount of the time in doing several type of apps, and those applications sometimes are very much dangerous applications. Like there are several types of games that are available in the Google Play or any other app stores where you can check it's very much violent type of games, like it involves with murder, some blood. These type of games are available in the Play Store. So these are one type of games. If the particular person played for a longer amount of time, then negative emotions are generated in that individuals. So that's one aspect. Another aspect, if we discuss about like in the children, they are going to the school colleges, they can get bullied by different social media trolls. You have might be checked that people are doing suicide after bullying. So by only doing Facebook, or we might think about that this type of apps are very much innocent, but if that are being handled by some malicious people, then that can give a havoc effect on our mental health. So we need to discuss the healthcare from the physical health domain as well as from the mental health domain. So physical health and mental health both will be discussed in today's topic. Physical health, that will be discussed by recognizing the gestures. So we are going to try to do analyzing different type of gestures. From that gestural information, features will be extracted. From that, algorithm will be designed such that physical health can be tackled. Similar way, from the to tackle the mental health, we can capture the brain signals. So it's a signal, similar type of signal like a gesture. So if it's a brain signal or any type of signal, first what we need to do, we need to do the pre-processing to get rid of any sort of noise. After that, we need to go for the feature extraction. So for any type of signal, their suitable features need to be extracted. So that's the brain signal. After that, uh, that signal feature, from that features extraction, algorithm should be there, a classification should be there to understand the mental health of that person. So basically we are doing the gestures, this basically from the behavioral perspective, and the brain signal that basically belongs to psychological perspective. So this is particular topic that we are going to discuss healthcare in two broad domains, that's the behavioral as well as the psychological. And if time permit, we are going to discuss other domains of the healthcare as well. So first, we are discussing about the behavioral perspective. So from behaviors. So behaviors means from the different type of gestures we can that we generate in our day-to-day life to express our inner feeling. So what is basically gesture? Gesture is the way of communicating our own feeling to the other people without having, without talking, like without having any type of verbal communication. By our bodily movements, what we can communicate to the other person. Like if I give this type of like gestures like this, so this means I am welcoming you. So like different type of gestures have different meanings. So we are going to deal with the gestures from the healthcare domain, as today we are discussing in this particular topic. So here, with my supervisor, Professor Amit Konar, we have this particular book that is the gesture recognition. So if anyone from the audience is willing to work on that gesture, so you can go to this particular book. Here, not only in the healthcare domain, but gestures from different aspects that are being discussed in this particular book. So like the principles, techniques and applications of that particular domain of gesture recognition have been there, and for each chapter we have tried to incorporate a different artificial intelligence tool, like a different AI algorithm is used to solve the different gestural problem. So these gestures can be broadly segregated into two parts. First one is intrinsic or non-conveyed gestures, and the second one is extrinsic or communicable gestures. So what are the non-conveyed gestures? Just imagine you are in an interview and you are feeling very much tensed. So what some person can do, the anxious thought to for that, the person can start finger biting. But is the person willing to convey that he is nervous? No one wants to do that. No one who is present at the interview wants to communicate that I am feeling very much nervous. Everyone try to be, or everyone try to act like that person is very much confident in giving this particular interview. So this type of gestures, the person doesn't want to communicate. So that's basically a non-conveyed gesture or intrinsic gesture. Other type of examples of that, thinking over a solution, sighing. So these are the different type of gestures that belongs to the intrinsic or non-conveyed gestures. Next type of gestures that are extrinsic or communicable gestures. So that basically the gesture that we do to communicate certain things. So these type of gestures can again be segregated into two part: emotional gestures and non-emotional gestures. So what are the emotional gestures? Like how we express our emotions. If someone is angry, you can say that by checking their body gesture. So emotions can be of two types. One is the positive ones, and as well as there are negative. So positive gestures, so like happiness, surprise, relax, these are belongs to the positive gestures, and sadness, fear, anger, that belongs to the negative gestures. These are just the few examples of emotions. That apart from that, there are several other emotions present. So if someone is willing to work on the emotion recognition, you can search circumplex model. Different scientists have proposed their circumplex model, and so from that circumplex model you can understand how gestures can relate with emotions. So that is that you can go through by internet searching. The topic name is circumplex model, from where you can understand emotions and how the emotions, each type of emotion are segregated from other emotions. What are the different? There are basically four quadrants are there in circumplex model: positive, negative, and the velocity of the body. Like if it is an anger gesture, uh, so body movements will be very much violent. But if it is a fear gesture, it is also a negative gesture. Anger and fear both are negative gesture. But for fear, the people do not have violent hand movements. So that's the difference between two gestures belonging to the negative domain. So that can be understandable from the circumplex model. So these are belongs to the emotional gestures. Next, we are coming to the non-emotional gestures. So non-emotional gesture means the emotions with which or the gestures with which emotions are not attached, like a traffic police signaling, driving gestures, like to do or not to do. So these are signaling gesture. Instruction: if I say go to that place, that's a type of instruction. Responsive gesture, like supporting or refuting. So these are the non-emotional gestures. So to recognize these gestures, there are basically two ways. One is through image processing. So image processing basically to capture the emotion, to pre-process that image, to identify the human subject from the total image, and then do the other, like the apply the application, like the algorithm, and to classify that. So that's the emotion or the gesture recognition from the image processing. But today we are going to much more focus on the gesture recognition from sensors. So there are different bodily sensors available. So from that, uh, gestures can be, or the person's body orientation can be captured. That we are going to discuss today. For that, I'll be playing a video on kinect sensor. So kinect, that name came from the kinematics. It's basically developed by Microsoft, and this particular demonstration video has been captured in the Jadavpur University lab under the guidance of Professor Avit Konar. So I'll be playing this particular video. So
Hello everyone, I am Sriparna Saha and today I am going to demonstrate the working principle of Microsoft Kinect sensor. This device has an IR emitter, IR detector, a 8-bit VGA resolution RGB camera, and also it has a multi-array microphone. The name kinate has been derived from the word kinematics, as it can sense the human being in dynamic condition. Now, I would like you to meet our two subjects, Vishwarup and Toluka. Now, in the computer screen, you can see three outputs obtained from the Kinect sensor using software development kit version 1.6, which is freely downloadable from the internet. The Kinect has the ability to detect two skeletons at the same time. In the extreme left, the depth of the subject is acquired by the IR sensor. In the extreme right, the RGB video of 8-bit VGA resolution is acquired by the RGB camera. And in the middle, the skeleton of the subject based on RGB and IR data is obtained. Those skeletons are formed using 20 Cartesian joint coordinates in three-dimensional space.
So, is that was the video on kinet sensor where you have checked two subjects were there, and their corresponding body joint coordinate has been recognized by the kinet sensor. So basically, this kinet sensor that is compressed of an RGB camera. So RGB means red, green, and blue camera. So that is basically here you can check that's the RGB camera or the vision camera you have. Apart from that, it has a infrared projector, so it's a IR emitter and it's a IR detector. So these are the 3D depth sensor cameras. Why depth? So it's basically suppose it's an suppose just imagine it's a kinet sensor. So this is basically suppose assume it as the IR emitter. So it emits the IR, it goes to that subject and then comes back to the IR receiver. So what happens? You know the frequency of the IR with which you have projected it. So you know the frequency of IR. You know the time. You have which time you have emit that IR and which time you are receiving it. So you know the time of that. So from that you can understand the depth of that subject with respect to the kinet sensor. So you have a frequency. So from frequency you have the velocity. If you have the velocity you can, and you have the time, so you can capture the distance from the time of flight concept that used in the infrared emitter and receiver. So that is basically was there. So basically human body is recognized in three dimensional space. Why it's 3D? So from the image, capturing the image from the vision camera, you can understand the human body in X and Y coordinate, and from the depth, that is the distance of that subject from the kinet sensor, you can understand the third dimension. So Z dimension. So it's the X, Y, and Z dimension that can be understandable. Apart from there is a multi-array microphone is there by which voice is captured. By processing that voice you can recognize the voice gestures as well. But here in this particular topic that we are going to discuss today, we are not going to deal with the voice gesture. We are going to only discuss about the bodily movement gestures and how that can be used to solve problems in the healthcare domain. So there is a motorized tilt was there. To why is it needed? Tilt is needed to capture the human being properly. If the human being is outside the range of that kinet sensor, it can tilt it, adjust it to get the better view of the human being. There is a LED light emitting diode to depict whether the kinet sensor is getting proper connection or not. And the range of the kinet sensor is 1.2 to 3.5 meter. So within this range, kinet sensor works properly. And this Xbox 360 is able to recognize 20 body joint coordinate in three-dimensional space. So these are the 20 body joint coordinate. And the frame rate that we have considered here is the 30 frames per second rate. Next, we are going to discuss about the skeleton generation. So just have on video how that is being can be done.
Here, that leads to the Microsoft coordinate video that I have already mentioned. Now, just see in this particular slide, where while I was discussing this particular slide in
So here you can check over here particular one subject is there, and their subject corresponding 20 body joint coordinate is over here. So this particular is one type of a hands-on session where MATLAB will be used to create the skeleton view of that subject. So this particular video has sound. So just check that video, and then we are going to discuss if there is any doubt or not. So for that time being, I will be just switching off the video and the microphone.
the 20 body joints that are going to be.
Yeah, the voice is audible. Anyone can say.
Yes, ma'am, it is audible.
So you are able to recognize that 20 body joint coordinate that is audible to you, right?
Yes, ma'am.
Record recorded by the Kinect sensor. So now just see that is the position of the hip center is 1. So just look over here is that is hip center has been given J1. J stands for joint. That is a joint number 1. And everything is as per this. Now how this numbering has been there? That which one is the first? Suppose the hand right is in the 12th number. Why it is in the 12th number? Actually, whenever it's going to download the software development kit for this Xbox 360, these are the numbering present over there. So we haven't hampering the numbering. This numbering has been given by the Microsoft itself. Now these are the numberings of the joint. Now Kinect sensor has been run, so it has recorded some amount of data. Now how the data is going to look like? So after completion of the recording, Kinect sensor data is going to look like something like that. We are going to get the data in a .txt format. And here just see that is these are basically the coordinate values for each joint. That is one particular row is for one particular joint. Hip center is the first joint. So this total row represents the 3D value, that is three-dimensional coordinate value for hip center joint. Now, this is basically the x coordinate of the hip center. This is the y coordinate of the hip center. This is the z coordinate of the hip center. Right? Now, I have already told the z value can never be negative. Just see in the total data set there is no negative value. And why it can't be negative? For that, you need to look at to my this particular video, that is introduction of Microsoft Kinect Sensor Xbox 360. Now just come over here. So what is the meaning of this second row will be? That is the three-dimensional coordinate values for the spine joint. Same thing, this is for shoulder center, this is for head. So each particular frame is going to have 20 body joint coordinates. So this is row 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So these 20, that is 20 cross 3, these total values are for one frame. That is for one frame, we are going to get 20 rows and 3 columns of data. This is belongs to one particular frame, right? So now what is the data? That is this particular data. That is the second frame data for hip center joint for x coordinate, right? So now we can easily understand the data. Now come to the code. So, in this code, we can see that the dimension of string and the joint values are 20. That is, it is the XYZ coordinate values and these are the 20 joints as per this particular system. Okay. Now that this particular file is there in the .txt format and it is in the same folder where this particular .m file, that is the code for the feature expression, has been kept. So I just need to open that particular file, right? So that is the f open then data.txt. Now this is basically a pointer that's going to get you that this point we are going to scan the data. So by that pointer, just scanning the data and we are taking all the real values and that's why this is 1 to infinity, that is we are going to take all the data from that particular .txt file. So first point, that is this point will be 1, right? Now what is the numbering of this the last position of the data? While recording the data from the kinet sensor, we have no idea that how much amount of time we are going to record the data. Suppose sometimes the time is for 5 seconds we are recording, sometimes it could be 5 minutes, or sometimes it could be 5 hours we are recording the data. So we cannot know beforehand how much amount of data could be there. Right. So to write a code that is a general code or something like generalization to the code we have done to write it infinity. That means in, in infinite number of times you need to scan. That means that whatever be the last value present in the data, take the up to that amount of time, scan the all the values. Now, after this, we have made one variable. What is the meaning of this variable? I am going to come later on. Just for this particular scenario, just see that is I am taking a total variable. So total is the length of A, right? So that is length of A means that is how many values are there in this A variable. Now, how many frames are there in the total data we have captured? That is the total number of data present divided by the number of dimensions and number of joints, right? So size of A is what? Size of A is the number of frames multiplied by number of joints, and each joint has 3 dimensions. That is number of dimensions. So if I divide the total data by the number of dimensions and number of joints, we are going to get the number of frames. Now this is the initialization of one particular matrix. Right. So initialization has been done using the zeros value. So why we are doing this? From this you can understand it is a three-dimensional matrix. Right? So in this three-dimensional matrix, why we have done something like that? Suppose we need to call, we need to know the value for any particular joint. Take one joint, suppose the joint is retry. So 11th number joint, z number coordinate, that is dimension will be 3 and frame is suppose 50. So then what we need to call, that is we need to call f within bracket, frame value will be 50th number of frame, 11th number of joints, this value will be 11 and this dimension value will be 3. Then we are going to get what is the z coordinate value for right for 50th number of frames. Right. That is why we have made this three-dimensional matrix. Now in that three-dimensional matrix, we need to put the actual value. This is just the initialization using zeros. Now, so first loop we are going from 1 to number of frames that we have already calculated over here. Then 1 to number of joints, how many joints are there, then how many dimensions are there, and joints and dimensional values are already specified in line number 5 and 6, right? So and the values have been put something like this. That is f of ijk, where k stands for dimension. So that is this particular for loop will be run first, executed first, then this particular for loop, then this particular for loop. Right? And why this is in this format? Just see. First we have x coordinate for one particular joint, then that particular joint y coordinate, then that particular joint z coordinate. So first we, what is the innermost loop? That is the innermost loop should be along the dimension, right? That is the innermost loop should be So this is the innermost loop, that is for the dimension. Then after taking the all the dimensional values for one particular joint, we need to move to the next joint, right? That is the next for loop should be for the along the joint. Then after taking all the dimension values for all the joints, we are moving to the next frame. So that is the outermost for loop is for the frame. Now we have taken all the things in the F matrix. Now we are closing the file. Right. F close and FID. Same thing is that this FID and this FID. Same. Right? We are closing the file. Now it's very simple. We just need to plot the skeleton diagram of one particular frame. Suppose we are going to plot the skeleton diagram for that is 433 number of joints. So that is sub j is that, then iter is j. Then if this I have run this, that is if for all frames I have taken and one particular frame is over there, right? So then that is the this particular frame number we are going to run the, or we're going to get the skeleton diagram. Now this is the for the joint for I is equal to 1 to joint. So this will be joints means this will be just 20. Right. Now there is a scatter plot has been there and the three scatter three, that is three dimensional scatter plot will be there, that the recorded data are in three dimensions. Now there is a iter, so that is one which number of frame you are going to get the skeleton diagram. Then this is the I, right? I stands for this particular thing, that is this joint, that is joint number, which number of particular joint. Then this there is star r, right? So that is all the joints will be given. So just let me run this particular thing. Okay, sorry. Okay, so if I just run this particular thing, now just see. So initially that is the joint values have been plotted using the red star. Why? It has been written over here red star. So just see red star. Now plotting of only these red star are not enough. So why they are not enough? Let me come. Now just see. This is the result. That is, I have plotted all the joints, but can you understand what is the actual structure of the skeleton? No, right? You can see it is like something like a noise. So I need to connect the joint. So connect the joint means I need to uncomment this thing. Okay. Now, why these x and y are there? So plot three, basically three-dimensional plot, that is going to give you the line between joints. So just see why this is 4 and 3. So 4 stands for head, 3 stands for shoulder center. So just see between head and shoulder center there should be a line, right? Another just randomly take 10 and 11. So 10 is elbow right and 11 is wrist right. Just see elbow right and wrist right there should be a line. So this is how this is written. That is one particular, that is escape position value from the x vector will be joined with the escape position value of the y vector, right? So that is these two things will be joined, these two things will be joined, these two things will be joined, and that has been joined by the plot C function, and just see that is xi is joined with the yi for x coordinate. Then this is 2 for y coordinate and 3 for z coordinate. Okay, now the line width has been given to 1.5. So after running the total thing, we are going to get this particular tensor. Okay, now why this axis equal is there? If there is no axis equal was there, you just a second, let me run. Just see. If there was no axis equal thing, this type of figure we are going to get. So we are just uncommenting it and then get the run. So this is the axis equal figure, right? Now just check whether this particular code is running properly. So just let me make it 43. Now 43th number frame. Another skeleton we are getting. Now suppose the total number of frames is 558. So make it 543. Okay, that is another skeleton we are going to get. That is changing the frame number, we are going to get that corresponding skeleton. And if you check the workspace, we are going to get that is the how the values are there. Okay, so this is the code for feature, that is the code for generation of the skeleton diagram from the kinetic data. Now, if you can calculate the skeleton diagram, and that skeleton has been get got, or we have calculated three-dimensional matrix, that is the S matrix. Now, suppose you need to calculate the features. So, what could be the preliminary features? The preliminary features can be the distance between any two joints. So, how to write the code? So, distance between any two joints. So, that means you need to just write down Euclidean distance equation between any two code, and how to get that data, that from the S matrix, right? So you can easily write the code for that. Next, we can write the code for angle between two joints, that is suppose this particular, so we need to make this direction and this direction to vector, and then calculate the cos theta, then easily you can get. These are all the algebraic things, you can easily do it. And so this is all about today's lecture.
Okay. Is there any doubt up to this? If anyone has anything to discuss up till this particular point, so it will be great to interact with you all. Other than that, we will be going for the next part of the lecture. So, anything you want to suggest or any discussion? Okay.
If yeah, if anybody has any question, you can ask ma'am, or you can type in the chat box, or else we will proceed further. No, ma'am, I don't think so. You can
Okay.
proceed. Yeah.
Okay, we are going for, so this is what we have discussed, that is the generalized way of recognizing the skeletons from any type of gesture. Now we are going to do the gesture recognition in the healthcare domain. So corresponding to the healthcare domain, we have taken into consideration some of the disorders and their common symptoms and represented that common symptoms in their skeleton format. So these are some of the disorders that we have considered in this particular healthcare domain, and what could be their common symptoms and the skeleton things. So these are the few others disorders, their common symptoms, and the representation in the common symptoms in the skeletons. And for each of the case, kinetic data has been captured, and that is being processed using the code that is being discussed. So we are going to discuss a very preliminary work over here, where a triangular membership function, so that is a fuzzy membership function, is used to recognize the real-time gesture in for the physical disorder recognition. So this is basically the flow chart of that particular work, where you can check. There we have told that there are two domains are there. One is the healing mode domain, and this is the tracking mode. So what is doing? So basically, kinet sensor is placed in one part of the room of any person. The person is kept on moving. So the person's body gesture is being recognized by the kinet sensor. From the kinet sensor, we are whatever with the data we have captured, from that we are generating the skeletons. From that skeleton, we are having some features. The features can be Euclidean distance or angles. From that, fuzzy membership functions have been developed, and then fuzzy matching is done with respect to a disease uh, database that is present over here. Now, if any disease is detected from the skeletal information, we can say that the person will be giving some remedial exercises. So warning will be given to that person, and the person will be told to do some remedial exercises such that the person can be treated properly. So that is basically the healing mode. And to do this particular thing, we need to take into the help of doctors. We are not saying that this particular work is going to suppress the efficacy of doctors in our society. Absolutely not. Doctors are very much important or integral part of our society. We are going to develop this particular, not this particular algorithm or any type of algorithms in the healthcare domain with and only after uh, taking the help of the doctors only. Without their doctors, we cannot say that this particular disorder belongs to this particular disease. And for if that particular initial gestural information we are getting, for the initial symptoms we are getting for particular disorder, what could be the exercise, so those will be prescribed by the doctors only. So whenever you are going to do any work in healthcare domain, not only this particular work, any other work in the healthcare domain, do consider taking the help from the doctors from their knowledge. So that is the healing mode. And if the person is not showing any disorder that are related to any disease, so you can go to the tracking mode. And this is basically the disease, and their corresponding physiotherapy is going to be the prescribed by the doctors over here. So these are the different subjects that they are that we have captured, and the disorder name, their corresponding gestures, and their skeleton image, and what are the feature vectors we are recognizing over here that can be checked over here. So these are the different membership functions. These are very preliminary concept. We are taking about the type 1 fuzzy membership function over here. So this is the triangular membership function. This is the Gaussian membership function. So what we need to know about the triangular membership function, this alpha, beta, gamma values. Whereas for the Gaussian membership function, the mean and standard deviation need to be known. And if it is, as it is a fuzzy set, the values of the membership function will lies between 0 to 1. In this particular range it will be like, so minimum value it can be 0 and the maximum value it can be 1. So these are for several persons in the training data set. From the several persons for one particular disorder, we know that corresponding class as the training data set, and whatever we are doing that belongs to the supervised classification or supervised learning domain. So here, whatever with the data we have got in the training data set, they have their corresponding class labels present. So from each of that, we for one particular disorder, so suppose the disorder is lumbar spondylosis. So for that particular disorder, we have several persons data. The person's data has been processed, and for one particular feature, whatever be the values we have got, that we have kept in one particular file, from that particular values from several persons showing the same symptom for same particular disorder, we have generated the fuzzy membership curves like this. So these are the membership curves that we got from the training data set. This is a fuzzy matching algorithm. Like we have some disorders present in the training data set that need to be matched with the unknown data that we are getting in the testing. So for if we use triangular membership function, so based on each of the subject, we have considered over here 15 number of subjects, so 1 to 15. For each of the subject, this is the accuracy curve. Each value is in the percentage, and for Gaussian membership curve, this is the accuracy values that we get. So here it can be easily concluded that our triangular membership values are giving us better result with respect to the Gaussian membership curve. For as each of the case, blue line is higher than the red line. Only over here, that is only for this particular second number of subject, we are getting higher values in Gaussian, but in taking into consideration all the subject, triangular membership function is our best suited one. So, if you are trying to publish any paper showing your particular algorithm is giving best result is not enough. You need to justify, you need to compare your work with the existing literature present. So our particular research work has been compared with all the other existing works where uh, kinet sensor is used in the healthcare domain, or other than healthcare as well. Like in this particular one, like it's not in the healthcare domain, but kinet sensor is used to capture the gestures. For each of the case, you can check over here. Our particular algorithm is showing better result. So we can say in this particular domain, a triangular membership curve is giving us better result. So that was the very preliminary one where we have used a type 1 fuzzy set. Next, we will be discussing about type 2 fuzzy classifier, where this particular one has also been developed for the pathological disorder recognition one, and this particular where another one that we have used the ensemble classifier approach to gesture recognition healthcare, that is also using the kinet sensor. So, this particular one where we have developed the type 2 fuzzy classifier. So, already discussed how type 1 fuzzy membership curve can be generated. After generation of the type 1 fuzzy membership curve, we need to go for the secondary membership curve. So, in this particular work, how we have done the secondary membership curve, we have taken into consideration a very simple example of how grading system is there. Like grading system, like one particular student has written, suppose given the math exam. So for that particular student, if I am giving that particular student 100 out of 100, so it's very much certain that the student is going to get 100 out of 100 by all of you present over here. So, and also the same thing for the certainty of getting 0 out of 100 is also very high, but the certainty of getting 50 out of 100 is very low, or it's lowest. If someone is getting 50 out of 100, it can get, or that particular student can get 51, 52, or 49, 47, these type of marks from all of you. So to get a highest mark like 100 out of 100, or to get 0 out of 100, has got the highest certainty. So for those, we have given the secondary membership card values as 1, and for the values that in the range of this 50 and that range, the membership function value in the secondary curve is given as the lowest one. And here the lowest we have taken as 0.3. Based on that, secondary membership curve is generated. And in this particular work, we have developed the ensemble classifier. So, if the name suggests, it is basically a group of classifiers. So, why we need a group of classifier? It sometimes is much more reliable to get a result from a group of classifier, not only trusting one particular classifier. That's the efficacy of ensemble classifier. Here, the base classifier that has been chosen, that is the tree classifier. So it basically creates a binary tree where each node is going to operate on one of the features from the dataset. The predictions of the individual base classifier, like the here the base classifier is the tree classifier, that are combined based on weighted voting to decide the class of the test samples. So this ensemble classifier can be of two different types, boosting and bagging. Boosting is, that is came from the word of adaptive boosting, that's a short form of adaptive boosting. What happens in the adaptive boosting? Just check these particular ones. There are two class of data is there. One is one class of data that is represented by the circles, another class of data that are represented by the squares. Okay, and this is basically the fault line is the hyperplane by which we are going to segregate this class of data with the square class of data. So if the class of data that present left part of this particular line, the hyperplane, we can say that the circles are the class that belongs to the circles that are properly classified, and the data that belongs to the right side of this hyperplane, we can say that the square data are properly classified. But here you can check this square belongs to the left, so it's basically misclassified, and all the other circles over here, those are also misclassified as these are in the right side of this hyperplane. So what does it mean? So what actually boosting does what the misclassified ones are given much more importance or much more traced. So these are giving the misclassified points are giving much more traced, and based on that hyperpins are adjusted such that we are getting a least number of misclassified data. Here you can check least number of misclassified data are present. That is the concept of adaptive boosting, or short form as boosting. Next one is bagging. So bootstrapping, that how it done. So it basically, the concept of this is a total training data set that we have. So total training data set, suppose the size of n. From that total training data set we are taking a sample or random sample of the total training data set. So it's a basically, suppose x% of the training data set is there, so that is the bootstrapping size is this. This is fed to a classifier, a base classifier, and as it's an ensemble classifier, so many number of classifiers are running at parallelly. So from this classifier, we are getting a result. Again, as data is captured from here that pass through the classifier. In this way, we are getting the result from n number of classifiers. And over here this is iterated t number of times, and each time we are taking into consideration random sampling to have the diversity in the data. After that a majority voting is there to obtain the final output class, that is the bootstrap aggregating or batting. Now this particular work is done on three age group: 25 to 30 years of age group, 30 to 35 years of age group, 35 to 40 years of age group, and then comprising all the data set we have comprised and make an overall data set. And for each of the case, the two classifier or ensemble classifier in two ways, adaptive boosting and bagging is being applied, and you can check for each of the cases AdaBoost is giving us better result. That was based on the mean accuracy. Here we have considered the mean processing time. So getting only accuracy is not enough, we need to give the result in the mean least amount of time possible. So for adaptive boosting you can check least amount of time we are getting over here. So for each of the case, time required for the AdaBoost is also lower. So that is the processing time. So if you are interested in writing any research work in where different algorithms is going to be com- compared, so then you can take into or you can compare the algorithm with the other existing algorithm in the concept of accuracy. As apart from that accuracy there are several other performance metrics that are present, like recall, that basically the effective that defines the effectiveness of a classifier to identify the class levels. So recall equation is this, that is the true positive and this is the false negative. So total number of class we have, that is the capital C, and for one particular small class, that is small c, is there. So you have, suppose a class where you are going to recognize six particular disorders, so capital C value becomes 6. So that is the recall. Next we have another performance metric, that is the precision, that is the degree of agreement of the data class levels with those of a classifier. How precise your algorithm is, that. And this is the false positive, and all the values of true positive, true negative, false positive and false negative are coming from the confusion matrix. Next, we have the accuracy, that's the overall correctness of the predictive model. This is the corresponding equation over here. Then we have F1 score, that is the weighted average of the precision and recall. Like if you calculate the precision and recall, you can calculate the F1 score. Then we have average error rate, that is calculated by this particular equation. So why we have given that, as each of the case ensemble classifier is compared with all the other existing ones. So these are the values, that are the mean values we have got after running the algorithm, each of the algorithm for 30 number of times, and for this particular age group, and these are the standard deviation values the classifiers are showing. So now in this particular age group, you can check the best one is the ensemble classifier. As for ensemble classifier, recall, precision, accuracy, F1 score, all are best. If we're going to need to find out the second best algorithm, then FCM is your choice. SVM is the support vector machine. KNN is the K nearest neighbor. This is the neural network. This is the fuzzy relation. This is the radial basis function. So this is that we have discussed that from the behavioral perspective. So if yes, FCM is fuzzy Siemens. One doubt is there in the comment section, that is FCM, so it's fuzzy Siemens. So anything, this one particular module is completed. So anything, if anything want to discuss, just a 10 second gap I am taking, only 10 seconds. If anyone have any doubt or anything want to discuss, please let me know by unmuting yourself or typing in the chat box. No, actually today I haven't planned for ensemble classifier coding. These codes are available. These are basically very preliminary coding. These are available in, like, if you do Python or MATLAB, these coding are available, easily available in the GitHub. You can download those codes or you can understand from those. Whatever we have planned in the hands-on session, those are basically what is not available freely in the internet, like the kinetic sensor, how the skeleton can be generated. The next one we are going to discuss about the EEG sensor data recognition. So those whatever not available in the internet or not very known techniques, that we have planned for hands-on session, hands-on as well as in the theoretical aspect. Uh, like if next any in future, if we can get a chance to collaborate, then it might be we are going to discuss about, if you want we can discuss about the coding of the ensemble. Okay, so no more doubts are there, so we are moving for the next topic, that is the from the cognitive aspect, how AI can be beneficial in the healthcare domain. So we are going to discuss about from the psychological perspectives. So what we can have over here, so we can have recognize or capture the brain signals. So in our brain there are several lobes are there. For each of the lobe, they have their uh, associated functions. Based on that, if we can recognize the signals from each of that lobe, we can understand what the person is basically doing in the cognitive domain, and from that the psychological perspective analysis can be done, and that can be done using the AI algorithms. So here we are going to take the application, or the application domain we have considered as the adverse gaming. As already discussed, there are several types of gamings are available in the internet, where somewhere there are very violent games are there that basically tends to develop negative emotions or adverse effect in our human brains. And there are some good games as well that basically try develops thinking capability. So we need to segregate which games are good for our children and which games are not good. So if we can understand the gaming impact, so we can take it very simple way, like, okay, so someone is in doing only games, what can be the harm? what can be the most harm in just only playing games in mobiles? The l- effect can be goes up to suicide. You might have heard the blue whale scenario or the Momo scenario, where people have been made to commit suicide by only playing games. So what we can do, what if we can, if you have gone to the Google Play, you can check every application have given got their likelihood values as their rating. Like if I like to play certain type of game, I can give that game rating as 4 out of 5. But whether the game is giving us positive or it is making our brain functions in the positive way or not, if that can be recognized, that is basically will help in the parental guidance. So parents can understand from that rating, okay, so this particular game has negative impression on our children, so I'll make it stopped, or I will not going to give this to my children to play this particular game. So this particular also can be done in two ways, like the signal can be captured in two ways. One is the facial expression from that, like measuring changes in emotional expressions. Another way of doing it using electroencephalography, that is the EEG, that basically captures the brain signals. So that is measuring changes in emotions and cognitive load. These are the two ways of analyzing the adverse gaming effects on individuals. So here in this particular paper that I have worked on with one of my BTech student, and he has done a very good work in analyzing the adverse gaming effect on emotions from the image processing domain. Like he has processed the image, and in the classification has been done using the neural networks mode. So this particular one, that is from the first one word that we have told, that is the from the facial expressions, how emotions can be recognized. So this is the basic block diagram of that particular word. One particular subject is playing the game. At that time, the frontal camera can be activated after a certain interval of time. Like frontal camera gets activated after 2 minutes or 3 minutes of time, and then the facial image can be captured. Like the person is playing the game at that time, facial image is capturing. So we are going to capture the facial image after certain interval. After the recognizing the facial image, we can calculate the features. Here, several type of features can be calculated, but in this particular one, we have considering capturing the heart-like feature. So, heart-like, what is heart-like feature? That we are going to go later on. After that, first stage of classification is done to understand whether that particular image is compressed with a face or not, whether face can be properly captured by that frontal camera. If the front face is properly captured, then that will be processed to the second stage, otherwise that image will be discarded. So first stage is classification is done also using back propagation neural network. This face and non-face classification is there, whether properly face is captured by the frontal camera of the mobile, yes or no. After that, five different type of emotions belongs to the positive and the negative domain, that is being classified, and for each day how many number of positive, how many number of negative emotions are generated, day wise calculation. This is the 50th day graph. For in this particular day, you can check this many number of happy emotions are generated, this many number of surprise, as well as this many number of angry emotions are generated. So that's the score is being calculated, and this score is being taken into consideration on a day by day basis, how each day passing, how the different emotions are changing in the subject. So this particular work is implemented using the MATLAB, where BPNN, back propagation neural network, is implemented. So just check over here, this is the data set that we have captured over here. So this is the algorithm for the BPNN. So how this is being done, this is one particular data set over there. So this data set has certain number of rows and certain number of columns. So here, whatever be the, this is the feature vector we have. So here the number of rows denote number of features extracted per sample, as well as the number of columns denote the number of classes multiplied by the number of samples taken from each class. So this is the particular feature vector that is there. So this one that shows us, that is the target vector. Here the number of rows, like this is, that is the number of, denote the number of classes, and the number of column denote the number of classes multiplied by the number of samples taken from each class. So what we can check over here, just check over here, it's the number of column. That is the number of column for the feature vector will be equal to the number of columns for the target vector, as both of the cases number of columns is equal to the multiplication of the number of classes and the number of samples. But in the feature vector, number of rows are the number of features extracted per sample, as well as over here, that is the number of rows denote the number of classes. And this is the unknown vector, that is in the testing dataset, one particular sample from the testing dataset is there. Here it will be only one particular row and number of one particular column is there, and number of rows denote the number of features extracted per sample. So in the feature vector, number of rows, that is the number of features, that will be equal to the number of rows in the unknown vector, that is also the number of features extracted. So we have a feature vector, we have the unknown vector, and the number of rows will be equal in both of the cases, as that going to signify the number of features extracted per sample. Here we have taken into consideration 1200 features are extracted for each of the sample. So, and over here the feature vector, that is the number of columns present in the feature vector, will be equal to the number of columns present in the target vector. Each of the case BL, that is the number of classes is 16 and number of samples taken from each class is 4. 4 into 16, that if you can represent the Excel, that will goes up to BL number of the cases. That is there. And we have put ones over here in the target one, target vector y is going to represent when the sample belong to that particular class. So this is, that is this one means these particular samples that belongs to the 13th number of class. These particular samples that belongs to the 14th number of class. Similar way, each of that one means where it belongs in this particular 1 to 16 number of class. So this is the code for the backpropagation neural network. So first, it is also written in the MATLAB. In the next session, we are going to discuss some coding in the Python as well. So what we have done initially in the first is the clear all, close all, and CLC. So clear all means whatever be written in the command, that is whatever be there present in the variables, that will all be clear, such that no garbage value is there. Close all means whatever be the result we have obtained in the graphs format or the tables format in the MATLAB, that will be all closed. Then CLC, that means basically whatever already written in the command window, that will be cleared. Now here we have the input is as the Excel read of the fv.xlx, like that is the feature vector is stored in the Excel format, that is being read over this particular one, and that is the variable that we are getting as the input. Next we are getting a target one. So target is there, target where the class levels are mentioned, that is also in the Excel. So that is being read over, and the variable that is created as the target. And how much time it takes to run this particular code, for that we have tick and talk method, that is very common in MATLAB. Like tick, it's going to start timing, and talk means it is going to stop the timing, and whatever be the values present in this, that will be compared, and we are going to giving the runtime of running on application. So it's this particular tick and talk can be applied in any algorithm, not only in BPNN, but for any particular algorithm. Whenever you are running in MATLAB, you can use tick and talk to identify how much time or how much run time this particular algorithm has. So we have next, we have the hidden layer size as 10. So you know it's a back propagation algorithm. So it's a multi-layered feed forward architecture. So in that multi-layered feed forward architecture, the layers that are connected in the input side, that is basically the input layer, the layers that are connected in the output side, that is the output layer, and in between input and the output layer we have the hidden layers. Here we have considering 10 number of hidden layers over here. And this is the net that is being designed, that is the feed forward net. It's a feed forward algorithm. So there might be one difficulty in understanding why we are calling it back propagation again as the feed forward. Feed forward architecture means the data is transferred from the input side to the output side. From input, the hidden, and then output. Data is passed. After the result we are getting in the output side, we can get error. Suppose we wanted the value as 0, but we have got the value as 0.1. So 0.1 is our error. So that error can be minimized using back propagation architecture that based on the concept of gradient descent. So what happens so far? Whatever in the output side, whatever be the errors we get, based on that errors, the initial layers weights need can be adjusted. Here weights are only adjusted, no data is passing. So it's a feed forward architecture. Feeding, that is the data feeding, is from the input side to the output side. But the weight adjust or weight adaptation is from the output side, and one layer up to in this goes on and it comes to the input side. It's only the weight adaptation, that is the back propagation architecture. So we have a feed forward net where the hidden layer size is 10 and it is 10 as the gradient descent is taken as the error adaptation one. And this is the learning rate, that is training parameter dot alert, that is the learning rate. Here the value is 0.05. It is not mandatory to give this value, automatically a value will be taken, but we have given us as this 0.05. Epochs, how many times the algorithm will run, that is has 3000. The goal is that how much amount of error we can tackle, e to the power minus 5, that is the amount of error we can, up to we can consider the algorithm as that. If it's a real life problem, getting a zero error is always not possible. Sometimes getting a very fraction of minute amount of error we can need to deal with that. And the data set, the total data set will be divided into training, validation and testing. So what is the applicability of each of the data set? Training data set means the data set by which you are going to train the algorithm. After training of that algorithm, the algorithm will be validated using the validated data set. Some minor adjustment can be there in the functioning of that algorithm. But whenever you are doing the testing, no adjustment is there in the training parameters, but only the testing result are shown, and based on that we are calculating the accuracy, precision, those performance metrics. We have already discussed the values and how the algorithm is going to perform in the real life scenario. That is the testing data set. So the total data set that we have captured, that 70% belongs to the training data set, 15% belongs to the validation data set, and 15% the testing data set. Now we are initializing the net over here, and this net is trained with the net input and target, whatever with the values that there in the Excel files. Then the simulation is there. Then we have plotted the confusion matrix. Based on that, we can calculate the true positive, true negative, false positive, false negative values. If we get the values, we can calculate all the performance metrics values. Regression plot is there between the target and the output, like how much correlated the values are there. If the values are very much correlated, then we can say that we are getting good results. Then errors are there, errors are plotted over there, and then ROC curve is plotted. And this particular line, you already know, this is to get the how much runtime this particular algorithm has. Now this is the simulation part was there. After, if you give one particular sample unknown data set over here, so that is the unknown dot excel xlsx, that is the Excel file is there. So it is being read, and after passing it through the net, you can get what is the final result is got for that particular unknown data set. If you run that particular code using MATLAB, so you are going to get this particular curve. It is the in between where the training neural network is going on. Here, it is after stopping of that algorithm. So it is the in between run screenshot. It is the after completion of that. Here you can check the input is there. How many number of features we have considered? 1200. How many hidden layers are there? 10. How many output classes are there? 16. That is already written over here. Data division like training, testing, validation has done randomly. That is the random is there. Training is done using the gradient descent, like error is minimized using gradient descent. Performance is captured using the mean squared error. This particular screenshot has been captured when it is in the 907 number of iteration. That is from the epoch you can understand, and to get it 10 second millisecond time is required to up to got this, where the algorithm stopped at the 1301 number of iteration. It took 12 millisecond amount of time. The performance of that algorithm over you can understand over here, but the final gradient values you can check. Validation check 6 number over there, and all the plots that are there, the options were there. So this is the confusion matrix we got. So we have 16 number of classes, so it will be a 16 cross 16. So these are the output class and true class values are there. The values over there, the values should be that along the diagonal, the values should be the maximum ones. So this particular class belongs to this particular class. This particular class belongs to this particular class. So these are the maximum values should be there along the diagonal. All the values should be nearly equal to zeros. Then our algorithm is performing very good. So these are the output class along these are the target class we have. This is our regression plot you can get over here. uh, Next, this is the ROC curve. uh, that is the receiver operating characteristic curve is there. So for each of the class, so there are 16 number of class. So for each of the class, their corresponding ROC over is there. So ROC is calculated, that is the receiver operating characteristic. This plot is between the true positive rate and the false positive rate. That is the ROC curve is there. So here, this particular screenshot, you can check the performances over there. If we click this performance, you can get the mean square error over here. That is the MSE value, and for train validation and testing, the validation performance values are there for all the epochs. The code has been run. That is 1301. If we click on the training state, you can get the particular gradient values. How the gradient values are goes up to 0, 1. If we have the error want to have the error histogram, so for training, validation and testing, you can have the error histogram over here. And if we want to have the regression, so these are the plots you can get. So this is the back propagation algorithm, how that can be run. uh, so if any doubt is there, you can ask, or we'll be taking, I think ma'am, we are going to take 10 minutes break right now, right? If any doubt, you can ask me, or we'll be taking 10 minutes of break.
Yes, anybody, if you have any doubt.
Okay, so as no doubt is there, so I think I'm a very good teacher. You understand everything, whatever I'm teaching. So, okay, so we are taking 10 minutes of break. After 10 minutes, we are joining from after how the BPNN can be applied in our particular domain. Okay, thank you till that time.
Thank you, ma'am.